Hello, my name is Jesus Iriz, and I'm going to present to you our work on a smart equalization based on the classification of musical genres by Jesus Iriz, Miguel Ángel Patricio, José María Molina, and Antonio Berlanga. As an outline, first I'll show you a brief introduction to what our work consists on, followed by a proposed architecture for the solution, the experimentation and results, and then some conclusions. Finally, we'll show you a demo of the effectiveness of our system. The goal of this project is creating a smart system able to equalize or improve the quality of a music track. The way we are doing it is by classifying the music in a distribution of the most common musical genres and applying the most popular equalization parameters for each genre to the song. In that way, we expect not only getting better quality on the music tracks we process, but also understanding more deeply the characteristics and properties that lay behind them. For that, we take an audio file as the input and process it to generate its MFCCs, or male frequency substrate coefficients, a distribution of numeric values which represent the sound's frequency strength over time as a 2x2 matrix. Then, we feed those values to our trained convolutional neural network model to generate a probability distribution of a set of musical genres. Finally, the system merges those probabilities with some pre-established equalization profiles and creates a custom profile for the song. The MFCCs, or male frequency substrate coefficients, are a set of numeric values obtained from processing the original song signal. With those coefficients, we get a time-frequency relation for each segment of the song. The genres for the classification are chosen from analyzing multiple song and genres datasets such as DT-SAN and MSD, or Million Song Dataset. The list consists on the top 10 most common genres on all of them. Equalizing consists on raising or lowering the volume of a song's frequencies with the goal of improving its quality. This process is a somewhat subjective process because what may sound better for one person may not for another. The equalization profiles are obtained from popular music apps such as iTunes, which use what is commonly used as the best profiles for each genre. The proposed architecture consists on two convolutional layers, followed by a dense layer, a 1024-dimensional layer, and finally the output layer with the probabilities for the song belonging to each of the previous 10 genres. This architecture is based on the one used in Dilemma's recommending music on Spotify with deep learning, removing one of the convolutional layers to try and get a faster output without worsening the results. The input layer takes a 600 by 13 array of data, which corresponds to the 600 time slots and 13 frequencies. The way the neural network works is by analyzing the input, extracting some important characteristics such as constant bassline or repetitive percussion to finally conclude that a song should mostly belong to one genre, such as rock. This raises another question. Should we split the song and classify each fragment differently? Now I'm going to show you some experiments carried out with the song Gravity by Against the Current. The first experiment consists on obtaining a softened result from the network which emphasizes the most probable result from the network, leaving us with almost only one equalization profile for each segment. This function is called softmax. These are the results of applying the profiles to each frequency on each segment and how they vary on volume over time. On the left are the plain results, and on the right are the same results but interpolating their values so the changes over time are milder. The second experiment consists on removing the softmax function, using the three most probable genres and ponderating their profiles. As you can see, the results for the equalization profiles do not differ much from the softmax one, but the changes in volume are much slower and softer over time. As for the conclusions, the probabilistic method seems to produce more accurate results to the song's real genre. Also, interpolating the values produces a much softer volume curve, which in the end sounds better. And finally, as you will see in the demo, the system produces some really good quality results.
Running I get lost up in the clouds. Can you save me now? You are my gravity. Can you save